Welcome. Today's lesson is on the Octet Rule. The rule states that electrons are going to gain or lose electrons to obtain the noble gas valence. That valence is the outermost orbit where the electrons are, and there'll be 8 of them. That means stability. That means everything in that element is stable. So another way to look at it is elements are going to always want to gain or lose electrons so they can have that stable form. They want to have the stability in their existence. Well, to either gain or lose, like everything else on the planet, it costs energy. And they want to find the lowest cost energy. So in this particular case, what we're doing is, just like many of us, elements are going to take the least path of resistance, the thing that costs the less. Now let's take a look at an elemental point of view. And the question is really going to be, will it gain or is it going to lose? Is that element going to do which one? They all want to be noble gases if we want to anthropomorphize elements, but stability is the key in this. And depending on whether they're close or far away from the noble gases will really tell us whether they're going to gain or lose electrons. So the closer they are to the noble gases, the more they're probably going to gain an electron or two. So they're either going to gain a couple or they're going to lose a couple, kind of depending on how close they are to the noble gases. So let's take a look at it from a perspective of the element itself. And let's start with chlorine. Chlorine, if you take a look at it, if you were to actually count all of those electrons on the outermost shell or the valence shell, there would be 7 of them. If they have 7, it makes a lot more sense for them to just gain 1 instead of giving up 7. So for them, taking that 1 extra electron from some other element and incorporating it into the 7 other electrons so they can have 8, will allow them to be more stable, kind of like argon. Now let's look at the other end of the spectrum and let's take a look at lithium. Lithium is located in group number 1. And group number 1 is essentially the alkali metals. Now the alkali metals have 1 electron on the outside. It's a lot easier for them to lose 1 than to gain 7. But there's a problem with this one. If you take a look, it's right near the top. So lithium has just 1 electron on the outside. So it'd be a lot easier if they gave it up. But when they do give it up, now they're stable. Yeah, I know there isn't 8 electrons in the outer valence. The outermost valence is actually the first valence right around the nucleus, which means there's only 2 electrons for them to be stable. In that way, they can have stability by just giving up 1 electron. So let's take a look at something a little bit different here. Let's take a look at, all right, when there's a compound being made, how does all of this octet rule work? Well, one of the things is you got to know, like for instance, the chlorine, let's start with that. We need to know how many electrons in the outermost valence. In this case, there are 1, 2, 3, 4, 5, 6, and 7. So it makes sense for them to try to find 1 electron. Now, hydrogen has 1 electron, so it makes a pretty good partner for chlorine. So when the chlorine and hydrogen, if they're going to share that 1 electron from hydrogen, that makes 8. So both of which, because they're kind of sharing this electron, will allow them to be what we call a covalent bond. These covalent bonds then can share the electrons in their valences and then of course can be stable. Now let's take a look at this next one. This is called a Ionic Bond. Ionic Bond basically means the matching up of metal plus nonmetal. That will mean an Ionic Bond. On this one, they're not sharing electrons. What they're attracted to each other because of their charges. So chlorine, because of its valence, it's going to be -1, plus metal is going to be +1. So what will happen is they're not going to actually share an electron like we saw in the covalent ones. What's going to happen is we're going to take one of those, like for instance, a sodium has 1 extra electron on the outermost valence. So it has 1. So what it's going to do, basically what the nonmetal is going to snatch or take away that electron and put it right in its own valence. So now what it has 8 electrons in the outer shell, which makes it very negative charge. Whereas because 1 less electron is in the outer shell of the sodium, that makes it more positive. So now there's a connection between the two, because now they have a positive and a negative charge, and those are attracted together. And that actually is a stronger bond than covalent. So that's how the octet rule works. I hope that has helped you. And I don't forget, first of all, I want to thank you for watching this, but don't forget to hit the like or subscribe button. And just remember, we'll see you in the lab. Thanks. Bye.